Question 2, points A and B lie on circle C. The area of the sector of the circle enclosed by central angle ACB is 208 pi 45ths feet squared. What is the length of the radius of the circle? Okay, so again, we know that we're dealing with the area of a sector. So area of the sector, I'm noticing that it is given in degrees right here. So I'm going to use this formula because it's given in degrees. So the area is equal to, sorry, I'm going to click new equation. Area is equal to our angle, theta, or just represented by angle, which is going to be divided by 360. And then it's going to be multiplied by pi r squared. So right here, it gives us that the area of the sector is 208 pi 45ths. So I'm going to replace this area, because we know what it is, they give it to us, by 208 pi 45ths. Okay, and we do know what the angle is. It's 104. Then we have pi r squared. We are solving for r. So our goal is to have something that looks like 1r equals blank. Most typically it will look like this. R equals, because the 1 is implied in mathematics. So how we are going to solve this, I'm going to keep this. I'm going to just do it in chunks, so that we are all on the same page. So since these are all multiplying, if you go back here, notice there's the dot, which is multiplying, and then when you have pi r squared, that's multiplication too. So all of these are multiplied. And so we're solving for r squared, so the first thing I'm going to do is I'm going to undo the multiplication, since r has a squared attached to it. So what I'm going to do is I'm going to start creating forms of 1. So I'm going to multiply both sides by 360 divided by 104. I'm going to multiply this side by 360 divided by 104. So now we're going to have a new equation of 360 divided by 104. That's going to be multiplied. We still have 208 pi 45ths right there. 280 pi, sorry, I said that backwards. 280 pi 45ths. And that still equals, alright, 360 right here divided by 360 creates a form of 1. And 104 divided by a 104 creates a form of 1. So that reduces all down to 1. That was our goal. So 1 times pi is just pi. So we're left with a pi times, and r squared still is there. Okay, so we still have r squared being multiplied by pi. So now I'm going to divide everything by pi. Wait, let me do something really fast. So on this side we can combine numerators and denominators. So it'd just be 360 times 280 pi. The reason we can do that is because when we multiply fractions, we multiply the numerators across and the denominators across. So I'm just writing this all together in one fraction, which is completely fine. So now we're going to divide by pi to both sides, and we're going to divide this by pi. So we have in the next equation, we are now dividing by pi. That's what we did in this step, so we're going to tack that onto the denominator since we're dividing by it. And pi divided by pi reduces down to 1. So 1 times r squared is just r squared. So here I'm noticing that we have just r squared left, and so I'm going to actually jump over and open up a calculator and see if it will simplify this for me. So I'm going to do parentheses 360 times 208 times pi, close parentheses because that's everything in the numerator, divided by parentheses because we want to include everything in the denominator, 104 times 45 times pi, close that parentheses. That's going to equal 21.53. So we have 21.53 is equal to r squared. Now how we undo a squared is we square root each side. So then we would hit the square root of 21.5384615. I'm just copying this. That is equal to 4.64. And that equals, well, the square root of r squared. It's written over there now. Remember we had square rooted that. So the square root of 21.53 is 4.64. Square root of r squared is just r. So we did reach our goal because again 1r is just most commonly written as r. So the length of the radius rounded is 4 feet.